The voltage rating of the solid-state modules depends on the potential voltage that the cabling could experience. Since the arrangement is strictly meant for lightning surge protection and will not be installed with any electrical circuits, it is important to consider the voltage that can be induced on the cabling during a lightning strike. Lightning strikes can induce extremely high voltages on nearby conductors, including data and voice cables. The induced voltage can vary depending on the proximity to the lightning strike, the length of the cable run, and the grounding system. To determine an appropriate voltage rating for the solid-state modules, it is necessary to refer to industry standards or consult with a lightning protection expert. Generally, for outdoor cabling exposed to lightning strikes, it is recommended to use solid-state modules with a voltage rating of 100 volts direct current or higher. This provides a reasonable margin of protection against induced voltages while considering the limitations and potential degradation of electronic components over time. It is important to note that the voltage rating alone does not fully determine the effectiveness of the surge protection. The energy absorption capacity and response time of the solid-state modules also play a role in their ability to protect the equipment connected to the cabling. Make sure to select modules that are designed for the specific application and that meet the necessary performance requirements. When considering lightning surge protection for data and voice cabling, there are several important factors to keep in mind. Firstly, understanding the potential voltage induced by lightning strikes is critical. Secondly, lightning can generate extremely high voltages on nearby conductors. Thirdly, the induced voltage varies depending on factors like proximity to the strike, cable length, and grounding. Fourthly, for outdoor cabling, it's generally recommended to use solid-state modules rated at 100 volts direct current or higher. Fifthly, this provides a reasonable safety margin against induced voltages. Sixthly, the energy absorption capacity and response time of the modules are also crucial for effective protection. Seventhly, selecting modules designed for the specific application and meeting performance requirements is essential. And finally, consulting with lightning protection experts and referring to industry standards can further ensure the proper selection and implementation of surge protection measures. When selecting solid-state modules for lightning surge protection, consider firstly the potential for induced voltage on the cabling. Secondly, lightning strikes can induce high voltages on nearby conductors. Thirdly, factors like proximity to the strike, cable length, and grounding influence the induced voltage. Fourthly, for outdoor cabling exposed to lightning strikes, a minimum rating of 100 volts direct current is often recommended. Fifthly, this voltage rating offers a reasonable safety margin. Sixthly, the energy absorption capacity and response time of the modules are important. Seventhly, choose modules designed for the specific application and meeting performance requirements. And finally, consulting experts and referencing industry standards are beneficial for proper selection. When installing surge protection, consider that the distance between the protector and the protected equipment is important. Keep this distance as short as possible. Also make sure you have properly bonded grounds at both ends. A surge protector is designed to divert excess current to ground. Without a good ground connection, it cannot function properly. Also note that surge protectors have a limited lifespan. They can degrade over time, especially after repeated surges. Regularly inspect surge protectors and replace them when necessary. The type of cabling you use can also affect the level of protection required. Shielded cabling offers better protection against induced voltages than unshielded cabling. Consider using shielded cabling for outdoor runs to further enhance surge protection. The location of the outbuilding relative to the main building is also a factor. If the outbuilding is very close to the main building, the risk of induced voltages may be lower. However, if the outbuilding is far away, the risk is higher. Consider the surrounding environment. Are there any tall trees or other structures that could attract lightning strikes? If so, the risk of induced voltages may be higher. Install additional grounding rods near the outbuilding to improve the grounding system. This can help to reduce the voltage difference between the cabling and the ground. Proper grounding is key to effective surge protection. Ensure that the grounding system is properly installed and maintained. This includes using appropriately sized grounding conductors and making sure that all connections are tight and corrosion-free. Consider installing a whole building surge protector at the main electrical panel. This can help to protect all of the electrical equipment in the building, including the data and voice cabling. A whole building surge protector is installed at the main electrical panel and protects against surges coming in from the power grid. These devices can handle significantly higher surge currents than individual surge protectors. They also provide protection against surges on all circuits in the building. Consider a surge protection system using multiple levels of protection. This includes a whole building surge protector, primary protector blocks at both ends of the cable run, and surge protectors for individual devices. This can provide a more comprehensive level of protection against lightning surges. Regularly inspect the cabling for any signs of damage. This includes cracks, cuts, and abrasions. Replace any damaged cabling immediately. Damaged cabling can increase the risk of induced voltages and equipment damage. When selecting solid-state modules, choose ones that are designed for outdoor use. These modules are typically more rugged and resistant to moisture and corrosion. They are also designed to operate over a wider temperature range. The energy absorption capacity of the solid-state modules is measured in joules. Choose modules with a high joule rating to provide better protection against large surges. The response time of the solid-state modules is measured in nanoseconds. Choose modules with a fast response time to quickly clamp the voltage and protect the equipment. Solid-state modules are available in different voltage ratings. Choose a voltage rating that is appropriate for the application. A higher voltage rating provides better protection against high voltage surges. However, it can also reduce the lifespan of the modules. The clamping voltage is the voltage at which the solid-state modules start to conduct and clamp the voltage. Choose modules with a low clamping voltage to provide better protection for sensitive equipment. The let-through voltage is the voltage that the solid-state modules allow to pass through to the protected equipment. Choose modules with a low let-through voltage to minimize the risk of damage to the equipment. Solid-state modules are available with different types of connectors. Choose connectors that are compatible with the cabling being used. The insulation resistance is the resistance of the solid-state modules to the flow of current. Choose modules with a high insulation resistance to prevent leakage current. The operating temperature range is the range of temperatures over which the solid-state modules can operate without being damaged. Choose modules with an operating temperature range that is appropriate for the environment in which they will be used. The storage temperature range is the range of temperatures over which the solid-state modules can be stored without being damaged. Choose modules with a storage temperature range that is appropriate for the environment in which they will be stored. The humidity range is the range of humidity levels over which the solid-state modules can operate without being damaged. Choose modules with a humidity range that is appropriate for the environment in which they will be used. The altitude range is the range of altitudes over which the solid-state modules can operate without being damaged. Choose modules with an altitude range that is appropriate for the environment in which they will be used. The ingress protection rating is a measure of the solid-state module's protection against dust and water. Choose modules with an ingress protection rating that is appropriate for the environment in which they will be used. The flammability rating is a measure of the solid-state module's resistance to fire. Choose modules with a flammability rating that is appropriate for the application. The compliance standards are the standards that the solid-state modules meet. Choose modules that meet the applicable compliance standards. The warranty is a guarantee that the solid-state modules will be free from defects in materials and workmanship for a certain period of time. Choose modules with a warranty that is appropriate for the application. When installing solid-state modules, follow the manufacturer's instructions carefully. Failure to do so can result in damage to the equipment or injury. Solid-state modules should be installed in a location that is easily accessible for inspection and replacement. Solid-state modules should be protected from physical damage. Solid-state modules should be replaced when they reach the end of their lifespan or when they have been damaged by a surge. Solid-state modules should be disposed of properly. They may contain hazardous materials. Consult with a qualified electrician or lightning protection expert to ensure that the surge protection system is properly designed and installed. Lightning protection is a complex topic. It is important to get expert advice to ensure that the surge protection system is effective. Lightning surge protection is a critical aspect of ensuring the reliability and safety of data and voice cabling, particularly when running outside a building to a detached structure. The primary goal is to mitigate the risk of damage from lightning strikes, which can induce significant voltage surges in nearby conductors. Installing primary protector blocks at both ends of the cable run, coupled with solid-state modules, is a sound approach, but selecting the appropriate voltage rating for these modules is essential. The voltage rating of the solid-state modules dictates their ability to withstand and suppress voltage surges. Choosing modules with an inadequate voltage rating can render them ineffective, allowing surges to pass through and potentially damage connected equipment. Conversely, selecting modules with an excessively high voltage rating may reduce their sensitivity to smaller surges, potentially compromising their protective capabilities. Since the intended application is solely for lightning surge protection, without the presence of electrical circuits, the focus should be on the potential voltage induced by lightning strikes. Lightning strikes can generate extremely high voltages on nearby conductors, including data and voice cables. The magnitude of the induced voltage depends on several factors, including the proximity to the lightning strike, the length of the cable run, the grounding system, and the presence of any nearby conductive objects. It is crucial to consider these factors when determining the appropriate voltage rating for the solid-state modules. While a precise calculation of the potential induced voltage may be challenging, industry standards and expert recommendations provide valuable guidance. Generally, for outdoor cabling exposed to lightning strikes, it is recommended to use solid-state modules with a voltage rating of 100 volts direct current or higher. This rating offers a reasonable margin of safety, accounting for the unpredictable nature of lightning strikes and the potential for high induced voltages. However, it is important to note that the voltage rating is not the sole determinant of surge protection effectiveness. The energy absorption capacity and response time of the solid-state modules also play critical roles. The energy absorption capacity, typically measured in joules, indicates the amount of energy the module can absorb before failing. A higher joule rating provides greater protection against larger surges. The response time, measured in nanoseconds, reflects how quickly the module can react to a surge and clamp the voltage. A faster response time ensures that the voltage is suppressed before it can reach sensitive equipment. Therefore, selecting solid-state modules with appropriate voltage ratings, energy absorption capacities, and response times is essential for comprehensive lightning surge protection. In addition to these specifications, it is also important to consider the module's suitability for the specific application. Modules designed for outdoor use are typically more rugged and resistant to environmental factors such as moisture, temperature variations, and ultraviolet radiation. Furthermore, ensuring that the modules meet relevant industry standards and certifications can provide added assurance of their performance and reliability. To determine the most appropriate voltage rating for the solid-state modules, consulting with a lightning protection expert is highly recommended. These experts can assess the specific site conditions, cable run characteristics, and equipment sensitivity to provide tailored recommendations. They can also help to ensure that the entire surge protection system is properly designed and installed. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Proper lightning surge protection requires careful planning, component selection, and installation by qualified personnel. By taking these steps, you can significantly reduce the risk of damage to your data and voice cabling and connected equipment from lightning strikes. Understanding lightning-induced voltages on data and voice cables is critical for selecting appropriate surge protection. Lightning strikes can induce substantial voltage surges on nearby conductors, including data and voice cables running outdoors. The magnitude of the induced voltage depends on several factors. Firstly, proximity to the strike plays a significant role, as closer strikes induce higher voltages. Secondly, the length of the cable run affects the induced voltage, with longer runs accumulating more voltage. Thirdly, the grounding system influences the voltage distribution, and effective grounding can mitigate surge levels. Fourthly, nearby conductive objects can also affect the induced voltage. Given these variables, determining an appropriate voltage rating for solid-state modules requires careful consideration. While precise calculation can be challenging, industry standards and expert recommendations offer valuable guidance. A general recommendation for outdoor cabling exposed to lightning strikes is to use modules rated at 100 volts direct current or higher. This rating provides a reasonable safety margin to accommodate the unpredictable nature of lightning. However, voltage rating is not the only factor. Energy absorption capacity, measured in joules, indicates how much energy the module can handle. Response time, measured in nanoseconds, reflects how quickly the module reacts to a surge. Selecting modules with appropriate voltage rating, energy absorption capacity, and response time is essential for comprehensive surge protection. Consulting with a lightning protection expert can provide tailored recommendations based on specific site conditions, cable run characteristics, and equipment sensitivity. Remember to consider the module's suitability for outdoor use and compliance with relevant industry standards. Proper planning, component selection, and installation are crucial for effective lightning surge protection. Do not consider this as a professional advice.